Welcome to the deep dive. So imagine you're running a big tech company, right?
Okay.
You've got this amazing new gadget ready to launch, a really cutting-edge smart device.
The next big thing.
Exactly. But how do you figure out if this launch will actually, help sell your other stuff? Or will it accidentally steal sales from your existing products?
That's the million-dollar question.
Or what about when a competitor suddenly changes their price? What does that do to your sales?
Right. Ripples in the market.
Well, today we're diving into something that kind of acts like a crystal ball for this stuff. Cross elasticity. It's all about how the price of product A can totally shake up the demand for product B, even if they seem unrelated. You're going to see these hidden connections everywhere after this.
It's fascinating stuff.
Now, before we really get into the weeds, just a quick reminder. This deep dive draws heavily on material from Farhat lectures.
Great resource.
Absolutely. All the content, the examples we'll discuss, the explanations are derived from the comprehensive accounting resources over at farhatlectures.com.
Yeah, really thorough stuff there.
So whether you're studying accounting, prepping for the CPA exam, or you're already a professional, definitely check out the website. They've got extra practice questions, video lectures, detailed support, everything to help reinforce what we talk about today.
Solid recommendation.
And a big thank you to Professor Farhat for making this material available.
Yeah, definitely. And it's such a powerful concept, cross elasticity,
It really is.
because it uncovers these, well, sometimes surprising relationships between products, things you wouldn't expect to be linked, but consumer behavior shows they are.
Okay, so let's unpack it then. Cross elasticity of demand. What are we actually measuring? We're looking at how much the quantity demanded of one specific product, let's call it product A, how much that changes when the price of a totally different product B, goes up or down.
Exactly. And that's the key difference, isn't it? It's not about how product A's demand reacts to its own price.
Right, that's just standard price elasticity.
This is about the interaction between two different goods.
Connecting the dots across the market, basically.
Precisely. And the main goal here really is to figure out if these two products, A and B, are seen by consumers as substitutes or complements.
Substitutes or complements.
Yeah, and just getting that classification from this one metric, it tells you so much about how the market works.
So how do we get this magic number? There's a formula, I assume.
There is, yeah. It's pretty straightforward, actually.
Go.
You take the percentage change in the quantity demanded of our product A, and you divide that by the percentage change in the price of product B.
Got it. Quantity change of A over price change of B.
That's it. And maybe just a quick point on calculating those percentages.
Oh, yeah, good point. It's the change divided by the original number, right?
Exactly. Final minus initial divided by the initial. That initial value part is super important for accuracy. It's easy to trip up on that.
Right. Keeps it consistent.
It does.
Yeah.
And, while the size of the final number tells you how much they're related.
Like how strong the link is.
Yeah, precisely. But for just figuring out if they're substitutes or complements, the most critical thing is actually the sign. Is it positive or negative?
Ah, okay. So the positive or negative tells the story.
That's the first big takeaway, which, leads us right into asking, what do those signs actually mean in practice?
Okay, yeah, let's dig into that. Case one, substitutes. What are we talking about here?
So substitutes are basically goods that consumers see as interchangeable. They satisfy a similar need or want.
Like Coke and Pepsi. If you can't get one, you grab the other.
That's the classic example, yeah. Or maybe different brands of butter, or we'll see different smartphone brands.
Okay, so if they're substitutes, what does that mean for their cross-elasticity number?
It means the coefficient, the result of that formula will always be positive, greater than 0.
Positive. Why?
Well, think about it. If the price of, say, product X goes up...
People want less of it.
Right. And if product Y is a good substitute, what happens to the demand for product Y?
People will switch. Demand for Y goes up.
Exactly. So you have the price of X going up, positive change, and the quantity demanded of Y also going up, positive change. A positive divided by a positive gives you...
a positive number. Makes sense. They move together, in a way.
They do, in response to the price change. Our source material had a good example with smartphones, brand X and brand Y.
Yeah, I saw that. What was it?
So the price of the brand X smartphone goes up by 10%.
Okay.
And as a result, the quantity demanded for the brand Y smartphone increases by 5%.
So people are jumping ship from X to Y.
Looks like it. So you calculate it. Positive 5% change in Y's quantity divided by the positive 10% change in X's price.
That gives you 0.5, positive 0.5.
Bingo. And that positive sign is your proof. It confirms mathematically that consumers view these phones as substitutes. When one got more expensive, they bought more of the other.
That's really clear. You can literally see the substitution effect in that number.
Okay.
All right, so what about the other side of the coin? Case 2, compliments.
Right, compliments. These are goods that are often used together.
Like peanut butter and jelly.
Or cars and gasoline, printers and ink cartridges. Coffee and creamer is a common one.
Ah, okay. Things that kind of go hand in hand.
Exactly. Their use is related.
So how does that relationship show up in the cross elasticity number?
For compliments, the coefficient will always be negative, less than 0.
Negative this time.
Okay.
Why the switch?
Think about the coffee and creamer example. Let's say the price of coffee goes up significantly, by 15%, according to the example.
Okay, coffee's more expensive.
So what are people likely to do?
Probably buy less coffee.
Right. And if they're buying less coffee, what happens to their need for creamer?
They'll need less creamer too.
Yeah.
So the quantity demanded for creamer goes down.
Precisely. So look at the changes. The price of coffee went up, positive 15%. The quantity demanded of creamer went down, let's say by 10% in one scenario from the source.
So that's a negative 10% change.
Exactly. So you calculate negative 10% divided by positive 15%. That gives you
A negative number.
Yeah.
About negative 0.67.
Yeah. Yep, around there. And the source even gave another possibility where maybe creamer demand dropped by a whopping 32%.
Wow, okay.
Which would give you negative 32% divided by positive 15%, resulting in like negative 2.13.
So the exact number can change depending on how sensitive demand is.
Right, that's the magnitude we talked about earlier.
But the sign is consistently negative.
That's the crucial part for identifying complements. The negative sign tells you immediately these goods are used together. Price of one goes up, demand for the related good goes down. It's an inverse relationship reflected in that sign.
Yeah, you wouldn't stock up on creamer if you suddenly stopped drinking coffee. It clicks.
Exactly. So if we just sort of pull this all together, the real power of the cross elasticity number, initially at least, is in that sign. The direction.
Positive or negative?
Right. Positive coefficient.
Yeah.
You're looking at substitutes. Price of one goes up. Quantity of the other goes up too. People are switching. Negative coefficient. You've got complements. Price of one goes up. Quantity of the other goes down. People are buying less of the pair.
Simple when you put it like that.
It is, conceptually. And thinking bigger picture, understanding these links is just, it's vital for businesses, isn't it?
How so?
Well, for setting prices, for predicting how a competitor's move might affect you, for understanding why your sales might suddenly change. It helps decode consumer behavior.
Yeah, it moves beyond just theory. It's a practical tool, really, for seeing those market ripples before they become waves. And hopefully this deep dive gives you, the listener, a kind of shortcut to grasping these economic connections. Helps you stay informed.
It really should. And like you said, it's practical. Think about launching a new electric car.
There.
Understanding the cross elasticity between gasoline and electric cars could help you predict demand shifts if gas prices spike. Or how pricing your new car might affect sales of your existing hybrid models.
Yeah, are they substitutes or complements in the buyer's eyes?
Exactly. And this isn't just for car manufacturers, obviously. It applies everywhere. It's also directly relevant in fields like accounting, and especially for exams like the CPA. This stuff shows up.
Good point. So knowing this can actually help on the exam.
Definitely. It raises that question, doesn't it?
Yeah.
How can you use this understanding of cross-elasticity, maybe in your own field, or even just as a consumer, to predict how markets might shift or how new products might fare?
That's a great thought to leave people with. If we've sparked your interest today, definitely keep exploring this. And remember, farhatlectures.com.
Yeah, great for practice.
For sure. You can find more practice questions, videos, really nail down this topic. As we said, it pops up on the CPA exam. Understanding it could be key for grabbing some relatively straightforward econ points.
Easy points are always good.
Always. So until next time, maybe when you're doing your shopping, just look around. Try to spot the substitutes, the complements. Think about how a price change for one item might ripple out. You might be surprised what you notice.